Some of the important features of Java are: Java is a platform independent technology, right? Java is also a it is simply a hotspot technology, right? Then Java is object oriented, completely object oriented. It is high performance. Why it is high performance? Means it provides the facility of automatic memory management, and it has the facility of garbage collection. It provides the facility of garbage collection. Then it also provides you the facility of the exception handling, and all these things make it a high performance language, right? It is a secure language. It is open source language also. Actually, it is partially open source, but it is a free technology. It's not, you don't need to pay for it. It's a free technology, right? So these are some of the important points. And along with high performance, you can also write robust. You can write a robust. Robust means that Java is very tough technology. It is a very secure technology. In fact, robust keyword includes high performance and security only. Right? These are some of the important points why Java is so much popular with all the guys, right? So, and yes, now there is one more reason that now Java has been into the market for almost since 1995, so it has been 17 to 18 years. And any newly released language, like, it takes time for it to fix down the bugs and add the library. Now Java is at very mature position. Like, Java has all the features that anyone wants to program, so it is a very mature programming language. It is completely developed programming language. It's like that. So we begin with the first feature of platform independence. So Java is a platform independent technology. Now basically, actually, what is the reason that Java is a platform independent technology? This is a very great reason, and you need to understand why Java is platform independent. Actually, most of the languages such as C and C++, they are compiler based languages. These all are compiler based languages. Now what happens in compiler based languages? In compiler based languages, the program is or the compiler reads the whole program at once and then converts it into machine code, right? The compiler will read the whole program at once and will compile it into the machine code. It will read the whole program at once and it is going to compile it into the machine code. Now basically, this is how the compilers work. But there is one more. Languages like PHP, Python, Perl are interpreter based languages. They are interpreter based languages. In interpreter, what happens? Interpreter based languages are, they read the code line by line, and execute it, and they execute them, right? And where does Java stands? Java is neither compiler nor interpreter based language. It is neither compiler nor interpreter based language. So Java is neither compiler nor interpreter based language. What is then Java? Actually, Java is, we can say that Java is a hotspot technology. What it means by hotspot technology? It means that it takes the advantage of compiler as well as the interpreter. So Java takes advantage of compiler as well as the interpreter, right? So basically, first and foremost thing, for understanding all these features, first and foremost thing, we need to understand the architecture of the Java, how Java is basically running, and why it is platform independent, why C++ was not platform independent, and how come Java is present in cell phones and all the devices also. What is the reason for that? We need to properly understand the architecture of Java. We need to understand the architecture of Java. Okay. Now basically Java is a programming language where Java is a programming language where the source code, first we write the source code. The source code is written, let's say we write it in test.java. Now fine, test.java is actually first and foremost thing, it is compiled. We compile this test.java. It is compiled, right? It is compiled into a test.class. Now most important point to note is test.class is not a machine language. This is not a machine language. In C and C++, it is a source code file is directly converted into the machine language, and that machine language is executed. Right? But this is not the case in Java. It is converted into another language. This is language of compiler, or we also call it as an intermediate language. It is an intermediate language that humans cannot understand, at least, right? But yes, the compiler will understand further. So there is one compiler that is present here. The name of this compiler is known as JavaC compiler. This is known as JavaC compiler. This compiler will compile the source code into the intermediate bytecode. This is also known as bytecode. We call it a bytecode. Now bytecode is not a machine code. It is an intermediate code, right? Now this bytecode, what will be done? This bytecode will be fine. Now bytecode is generally given to all the clients. We give its bytecode to all the clients, right? Now actually this test.class is run by a virtual machine. A virtual machine is a separate software package that is responsible for running the Java programs, and this is the main thing that is present. Okay. JVM, Java Virtual Machine, the JVM. Everything goes on here and all the features are provided by this JVM only. This is known as Java Virtual Machine, right? Okay, so Java Virtual Machine. Java Virtual Machine, this is actually why it is known as a virtual machine, because basically if you want to run the Java program on any system, you need this virtual machine on that system. Right? On any system, basically you must have seen JRE, Java Runtime Environment. The Java Runtime Environment is nothing but it contains JVM only. It contains JVM along with some other additional packages. Now this JVM, what we are going to do with this JVM is going to read this. It is going to read this and it will actually run the program independent of the platform, right? JVM is actually responsible for reading the .class file and it runs it in a platform independent manner. How? This is also one more reason how. Yes, we will definitely understand how it runs in a platform independent manner. Correct. Now finally the output will be produced here. Output is produced here. So JVM is responsible for all the things. JVM is doing such it is executing in such a way that it will execute in a platform independent manner. If you want to run the program on cell phone or tablet also, that is not a huge issue. All you need is a JRE. That's it. So this is the same case in cell phones and all these things where Java is running. Even Android also runs on a virtual machine. The only difference is that it runs on a separate virtual machine known as Dalvik virtual machine. That's it. But in the other case, it runs on a virtual machine only. All the programs, they are running on a virtual machine, right? So JVM, correct. Now we'll just see how the things are going on. So first and foremost thing, I'll just try to demonstrate a small program before you so that you can just see how a small Java program is written. So I'll just do this Java, okay, and just make a folder as new, right here. I'll make a new text file. I'll write my program into text file only, and I'll save it as first test.java. I'll just go for all files and I'll save it as test.java. Save, right? It's saved. Now I'll open in a notepad. Okay. Now I'll go for class 1 or class test. Make the class with the same thing. If you do not understand it, please do not worry. I'll just explain each and everything step by step. But currently I am just trying to explain the architecture and how it works. So I need to show how a program works. We need to go with public static void main and string array. Alright. And this is here, and we need to go for system.out.println welcome to Shiva Softwares. We just got it. Just save everything. It's done. And if you see here, there is nothing else. Only test is present. Even if I delete this, only my test program is present, and the type is Java file. Right. Okay. Now if I just open this command prompt, okay, and I just go to this directory d java new, so I'll go to d cd java and cd new. Now I'll just go for java c test.java. So I can just go with java c test.java, and as I hit this thing, you just see a new class is generated. This is known as .class file. So a new thing has been generated now, and if you just open this and try to read it, it is a kind of unreadable file, right? But yes, it is understandable by the compiler. Compiler means my JVM is going to understand it. JVM will read this .class file in Java test. It will read this .class file and then it will print you the output. It is giving you the output. So basically it is a two-step process. First it is being compiled, and when you give the program to your client, you generally distribute it in form of .class files. That is the test.class. If you are giving this program, then you will be giving a .class file, and the client will have to install the JRE, and he will simply run the program on that JRE, Java Runtime Environment. Java Runtime Environment will have a JVM there. Right? Now JVM is actually responsible for making the program platform independent. JVM makes the program platform independent. Right? So Java Virtual Machine Java Virtual Machine is a part of JRE. It is a part of JRE, and it has following functions. The functions of JRE are, first and foremost thing is that it has a function of reading the .class file and loading it into reading the .class file and loading it into memory. After reading it, it will compile it. It will basically, it's already compiled. It will convert it into the machine code. It will convert it into machine code, and then after converting into machine code, it will run the program. Basically, the third step is having more detailed explanation. Right? We are very comfortable. It will convert it into machine code. Now, why Java is platform independent? My answer lies in these 2 points. And why Java is high performance? When I said that Java is neither compiler nor interpreter based. So what is the style of execution of the Java program that makes it neither compiler based nor interpreter based? Right? So it will So first and foremost thing, so this is what the JVM is actually doing. But in this 3-step process, it is doing some more processes that makes it high performance, and that makes Java a hotspot technology, right? So reading the class file and loading it into the memory, and second part is it will convert it into machine code. Now first we need to understand why the problem of platform dependency arises. Why programs are platform dependent. And basically this problem actually arises in the following manner, that Java is, if you see here, any language, suppose C, right? You have written your program here as 1.c. You write your program as 1.c, and then you compile it into, you're compiling it into suppose 1.exe. Now the process of converting into machine code is done by processor. It is done by processor. So let's say processor P1 has converted it into 1.exe, and the programming language of processor is assembly language. Means the complete computer world is currently running on assembly language only. Every language internally, it is internally converted into assembly language. Let it be Java, let it be C, let it be C++, .NET, anything. Because processor understands only one language, that is assembly language. Processor will understand only one language, that is assembly language. Now basically, assembler is a part that converts the assembly into machine code. Assembler is a part. So basically P1 generally has, let's say it has assembler 1. And P1 will convert it into 1.exe. And if we try to run 1.exe on processor P2, there is no guarantee that this will run on another processor, because there is no guarantee that this processor will understand all the machine code generated by another processor. And nowadays most of the machines are using Intel, so this problem has still reduced. But in earlier days there were Motorola processors, and even nowadays Macintosh uses Motorola processors and all those things, right? So basically the problem still prevails if you want to run on different servers, right? So one processor may not understand the machine code of another processor. This causes the problem of platform dependency, right? So one processor may not understand the machine language of another processor. So this causes platform dependency. How JVM solves this? JVM easily solves this. How? Actually what JVM does is, JVM converts .class file. It makes Java first creates a .class file. This is not a machine code. Now all you need to do is you will take this .class file to your computer, and in your computer JVM is installed. JVM will convert this .class file into machine code on the same computer. It will convert the .class file into machine code on the same computer and on the same platform. So basically the processor that will convert the source code into machine code can also run it. P1 processor is going to convert the source code into machine code. So it's very obvious that this processor will run its own machine code. So JVM provides the facility of converting the source code into machine code on every separate machine. Means if you take the code, then your JVM will convert your source code into machine code. If you take it, so your JVM will convert your source code into machine code, and definitely your processor will run your machine code and your processor will run your machine code. So basically JVM, what JVM does is, JVM converts the source code into machine code at time of running only. At time of running means when you need to run the program, only at that time it will convert it into machine code and it will run it. So this solves the problem of platform dependency. So hence the problem of platform dependency is solved. Easily the problem of platform dependency gets solved here, right? This specific process is also known as just-in-time compilation. The process of converting the source code into machine code only when it is required. It is also known as just-in-time compilation. So we can also say that what is just-in-time compilation? Just-in-time compilation converting source code into machine code when it's required, whenever it's required. So it is, and this also solves the problem of platform dependency, and hence the Java programs become platform independent, and hence the Java programs become platform independent. It's clear?